Good morning, good afternoon, good evening to the folks joining from different parts of the globe. My name is Noor Basha, Marketing Director at Winwire Technologies, and I will be your moderator for today's webinar. So today's topic for the session is Azure Search, which is cloud search service for web and mobile app development. So before we start, let me highlight few housekeeping items. During the webinar, please feel free to post questions and we will try to answer as many as we can at the time. Recording of this session and presentation will be shared to you in next 24 to 48 hours. So with that, let me take this opportunity to introduce you to my colleague, Mr. Abhishek Chandra, who is the today's session speaker. And Abhishek brings over 12 plus years of experience in the IT industry and is a senior consultant at Winwire Technologies. So with that, I would like to turn it over to Abhishek. Abhishek, over to you.
Thanks, Noor. So good morning and good evening to folks joining from different parts of the globe. Hello everyone and welcome to webinar on Azure Search. So my name is Abhishek Chandra and I'm working as a senior consultant with Winwire Technologies. And before we go ahead with today's webinar, I would just like to define the agendas of today's webinar. We'll be discussing about what is Azure Search and in which scenarios we should be using Azure Search. What are the benefits of using Azure Search? Then we will be creating and populating index and uploading the documents into that index. And this will be followed by demo in which I'll be showing you the code of how we have created and populated the index along with the demo. And then we'll have questions and answers if any. So please feel to post questions. We'll try to answer as much as we can towards the end of the webinar. So what are the scenarios in which we should go for Azure Search? So the answer is like if your app offers a lot of content, so in those scenarios your users will be more effective searching for what they are looking for instead of navigating and browsing. So one of the key scenarios is e-commerce. So providing a search option for e-commerce in today's scenario, it is essential because user expects it. You should be able to handle whatever your inventory are in the real time, and your search result should reflect this. So, and also there are scenarios like in e-commerce, especially in US, for example, on Black Friday and Cyber Monday, you can expect to have very high spike in terms of query. So you should be able to handle those many queries on those particular high demanding days. So with Azure Search, you can scale up or scale down as per the need and demand. The other use case for using Azure Search is applications which generate a lot of user content. So sites where there is a lot of user content generation, for example, websites where user provides review, rating, in all those types of applications. You definitely need to provide search options so that user can effectively search what they are looking for. Then the next is like any typical line of business applications, because a typical line of business application is accessed by looking through its UI until the user finds what he needs. If your application is very simple or the user knows your application very well, then this approach works. Otherwise, user finds it very, very difficult to use your application. However, when search is incorporated into these type of application, a lot of friction can be removed from the general user interaction, making it quicker and more efficient to retrieve information. So now let's see what is the relevance of search. Because search is relevant in today's environment because it is very simple. It is natural nowadays for users to use search because they have been using Google and Bing a lot. So that's why they don't require training as such. They already know how to use search in their application. Search as a tool. It helps user to drill down the right set of data what they are looking for. And as I told that user in today's environment expects search to be there in the application. So after having said that, why we should build our own search engine when we have Google and Bing and all those web search available? The answer is you do not have control on what Google or the Bing search is going to return you. So you want to control what information is returned from the search query and especially the order of those results. That's why you need to build your own search engine. it's a control that sets Azure Search apart from public offerings such as Google or Bing. Because with Azure Search, the developer can define what will be indexed and how the search results will look like. It is the developer has the control on what to written in terms of search results. As I said, in US, for example, on Black Friday, you expect to have high spike. If you wanted to have a control, you can increase the number of servers during those high demanding days to be able to meet that demand. And to define what's the right scope of searchable data. That's why you need to build your own search engine. The next point is like you need to align with business, because that's very important. Think of any online electronic store that has a premium tie-up with some, say, laptop company, and the laptop company is paying high percentage to this online electronic store. So the site search result needs to list that particular brand of laptop on the first in the search, and that's why the revenues and all these things will get driven by that. So owning its own search function has other benefits too, such as letting this particular company see what its customers are searching for, and then with that data we can analyze that and then take steps to align with the business. So to make the business to align with the business basically. So let's see, what is Azure Search? So Azure Search is Search as a Service solution that allows developers to incorporate great search experiences in their applications without managing infrastructure or needing to become a search expert. So it is a fully managed search service which you can use both for mobile as well as web app development. At a very high level, it offers the experience what end user is looking for, and the features, very features which developers require. So with that, let's talk about the advantages of Azure Search. As I mentioned that it can be used both for web and the mobile app development. You can very quickly get your indices up. We'll see in the demo also. You can easily scale up and down as needed. For example, on a days where there are very high demand, you will consider upgrading your servers. You can connect search result to the business goals with great control over the search ranking. You can load and automatically update with integrated indexes. So before you can search, you need to populate an Azure Search index with your data. You can make use of Azure SQL indexer to automate this indexing process, and it offers geospatial search to your application. So this particular geospatial support allows you to process, filter, and display geographic locations. So, for example, suppose I'm building some restaurant finding applications, and it would be great for me if that application can tell me some features there that through which it can tell me that what are the restaurants within 5 miles where my user is currently located. So that will be an awesome and added benefit. And in today's scenario, user expects these type of features in your application. Let's see how to go ahead and create an Azure Search service. So for creating an Azure Search service, you need to log in into the Azure portal. Once you have logged into the Azure portal, you have to pick a service name and a URL endpoint for your service. After that, you need to select a subscription. I mean, it's typical like you create any other cloud service. You have to select your subscription, and then you have to select a resource group for your service. If there is a already created resource group, you can use that, or you can create a new resource group. You need to select the location where your particular service will be hosted. After that, you select the pricing tier, which is either you can select the free, basic, or the standard pricing tier. Each has its own capacity and limits. So in the demo today, I'll be showing it to you with the free pricing tier, basically. And after that, you go ahead, create your service and provision your service, basically. So let's see at a very high level, how does Azure Search work? The typical usage flow in case of Azure Search will be, you go ahead and create an Azure Search service using the portal that we just now discussed. Once you have your Azure Search service up and ready, you can go ahead and create an index schema. Once your index is ready, you have to upload the documents to the index. And after that, you can start querying the Azure Search for results. You just query the Azure Search and you get the results back in a JSON format, which you can, as per the use case, you can display in your application. So to get started in application, basically must create one or more indexes in case of Azure Search. And defining the index schema includes like specifying what all field it will contain and setting various attributes for each field. So which will be seen on in our demo today. So each index will contain information that a search request can access, and it is the fundamental data storage of Azure Search. So the next thing is like populating the index, which can be done by supplying its initial set of data. So most often, like for example, for manufacturing sort of application, this will come from its operational database. However, an index can also hold the data from the other sources also. So once an index exists, the application can begin issuing searches against it and displaying the results. Let's see, what is an index? So index, to understand index, it is a persistent store of documents and any other constructs used by an Azure Search service. A document is a single unit searchable in your data. It is very much like a row in a SQL table. For example, an e-commerce retailer might have a document for each product they sell. So at a very high level, you can consider, if you are making an analogy with a SQL table, it's like index is conceptually similar to a table, and the documents are roughly equivalent to rows in a table. That will give you some understanding about what is index and what is documents. Now, field types and attributes in an Azure Search index. So as you define your schema, you must specify the name, type, and attributes of each field in your index. The field type classifies the data that is stored in that particular field, and attributes are set on individual field to specify how that field is used. It's like in any typical application how you define field and attributes. So some field types in case of Azure Search are like edm.string, collections, edm.boolean, and int32. And some field attributes are like retrievable, filterable, sortable, and one very important attribute is key. This key attribute provides a unique ID to each document, which is used for document lookup basically. Every index must have one key, so that is the requirement. And filterable attribute allows the field to be used in the filter queries. Sortable, like the name suggests, it allows query to sort searches using this particular field. Now let's look at creating an index. Once you have created a service, next you have to create an index. You can create an index by using a simple REST API or by using .NET SDK. In today's demo, we will be in the demo and the code walkthrough, we'll be seeing how to do it with .NET SDK. But for here, let's see this one with the REST API. So HTTPS is required for all the service requests. The create index request can be constructed using either a post or a put method. So when using post, you have to provide an index name in the request body along with the index schema definition. So this is the requirement for the post. With put, however, the index name is the part of the URL itself. So how it happens, like if the index does not exist, it is created. If it already exists, it is being treated as an update. One thing to notice here is that you can use only post one put or post in one. You can only post or put one index at a time. So a couple of things with respect to index name is like we have to some limitations are there basically in terms of naming. It has to be lowercase. It has to be start with a letter or number and have no slashes or dots, and it has to be less than 128 characters basically. So one thing to note over here is the maximum number of indexes vary by the pricing tier. Free service allows up to 3 indexes, and standard service allows 50 indexes per search service. So this is at a very high level. Now let us look at operating an index. What are the various ways of operating an index? So populating, there are 2 ways to populate Azure Search index with the data. The first option is to manually pushing your data into the index using Azure Search REST API or .NET SDK. The second option is to point to a supported data source to your Azure Search index and let Azure Search basically automatically pull your data into the search service. So there is the approach of pushing data into an index where we programmatically send data to the Azure Search, and the other approach is of pulling data into an index using the indexer. Now let us look at populating an index using indexer. So Azure Search can integrate directly with some common data sources, which removes the need to write code to index your data. To set this up, you can call the Azure Search API to create and manage indexers and data sources. An indexer is basically a resource that connects the data source with the target search indexes. Few scenarios in which you can use, and few ways you can use indexer are like if you wanted to perform a one-time copy of the data to populate an index, or if at a specified schedule you want to sync an index with the changes from the data source, then in those cases you can consider of using indexer. A data source is specifies what data needs to be indexed. It specifies the credentials to access that data and policies to enable Azure Search to efficiently identify changes in the data, such as your modified or deleted rows in a data table. It is defined as an independent resource so that it can be used by multiple indexers. So in this particular example, you are seeing data source connected to one indexer, but it is very much possible that one data source can get connected to multiple indexers. So Azure SQL DB, Document DB, and Azure Blob Storage are the currently supported data sources, which are being supported in today's environment, in the current environment. So setting up an automatic indexing is typically a 4-step process. First, you have to identify the data source that connects the data that needs to be indexed. Second, we create an Azure Search index whose schema is compatible with your data source. Once done that, we have to create an Azure Search data source. After that, we have to create an Azure Search indexer, and then we can populate an index after that. So let's look at populating an index using the Azure Search REST API. So basically, you have to consider here, you will be using a tool like Fiddler or Postman to post your request. So it is important to consider, look at request and response in this particular case. So your request URL, you will need the service name. So it will be like something like https, then service name .search.windows.net, followed by the details of index as shown in the slide, like /indexes, index name, etc. In the request header, you have to provide the API key. API key for the service you can get from the Azure Search portal, as we just now saw. I will show you how to get the API key in the demo. The body of the request contains one or more documents to be indexed. Documents are identified by a unique key. Each document is associated with an action like upload, merge, etc. Upload request must include the document data as a set of key value pairs matching the index schema. So let's look at an example how it will look like. So if you suppose you have an index for movies which have fields like title, year, etc., then for each particular movie, that is for each particular document in that movie index, you will have details like title as say Lord of the Ring, year as 2001, and so on and so forth. You will construct your request. you will post the request using tools like Fiddler or Postman, and you will get the HTTP response. So the response, you may get something like 200, which shows that it is successful, meaning that all items have been successfully indexed. If you get the response status code as 207, which means that at least one item was not successfully indexed while populating the index. Now, let us look at how to, at a very high level, how are we issuing the searches. So suppose a user wanted to went to a website or application and he entered the term whatever he's looking for, high heels in this particular example, or Intel i7 laptop or processor or whatever it is. Then in the application, it issue the search request using this particular text. It goes to your Azure Search service. Azure Search service, you hit search the index for this particular keyword basically, and it returns the search results. Once the search results is returned to the application, your application can create a UI with the return search result which are there in the JSON format, and it can display it as per the use case of that particular application. Now let's have a look at today's demo. And so before that, I'd like to show you the in the Azure portal to save some time. I have already created a simple search service. I have named it as wintest1.search.windows.net. So all the services will be prefixed with the search.windows.net. So if you can see here, I have a index by the name of movies here, and it has already some documents to it. So and you can get the keys and all those things by clicking on the keys icon over here, and you can get the keys for this particular search service. So in our code, let's see how are we doing? How are we creating the index? How are we populating the index, and how the search is being performed? Let's So basically, it's a sample application for creating and populating the index. So in the create index method, basically, let's see how we are creating the index. So first, we need to create a new search service client. So this object allows you to manage indexes. In order to construct one, you need to provide your Azure Search service name as well as the API key. So just now we saw that the service name and the key we can get from the portal. Once we have that, next we have to create an index by the name. We are giving the name of movies. So what is that? If it is, we are creating an index named movies and deleting it first if it already exists. So after that, then we can create a new index object with a list of fields that defines the schema of the new index. Each field has a name, data type, and several attributes that defines its search behavior. So over here, if you see, we have fields like ID, title, IMDb rating, year, and if you notice, for the ID key, we are telling that for its key attribute as is true, and for the title, if you notice, its searchable attribute is true because we will be searching based upon this particular title. Once we do that, we have to go to this function to apply the to populate the data. So till now, what has happened is index has been created. Now the next step is index needs to be populated. So over here, what we are doing, we have a list of movies in a dat file. So we are looping in this list of movies read from .dat file, and for each movie, we are creating a document. For each movie, we are creating a document, if you see here, and then for each document, we are creating an index action. If you see here, we are creating an index action with this operation as index action.upload, and then it is added to index operations. Over here in this particular example, data is indexed in batches, and in each batch we are uploading 1,000 documents. Now you have created the index and populated the index. Now let's go to how finally let's look at how search is being performed. So first, this particular method, search documents method, creates a new search parameters object. This is used to specify the additional options for queries, such as you may want to specify sorting, filtering, paging, etc. So in this particular example, we are setting only the filter property. The next step is to actually execute the search query. So this is done by using the documents.search method. In this particular case, we pass the search text to use as a string plus the search parameters created earlier. We also specify movies as the type parameter for documents.search, which tells the SDK to deserialize the documents in the search into an objects of the type movies. Finally, this method iterates through all the matches and return the search results. So let's look at all these things live in the action. So let me go through this particular a website which is making a call to this particular search service. Let me type in some. So basically, the expectation is if I type a name of a movie, it's going to search by the title of that movie and going to return me the search result. So for example, if I type war, it returns me all the movies which have the war title in it. Or if I type matrix, it will return me all the movies which have matrix key title in it. So so basically, I would like to conclude by saying that earlier creating your own search service and then managing over a time was a task requiring a high level of effort. So the goal of Azure Search is to lower this effort and bar. By providing a managed search service, it makes the life significantly simpler for the development teams that want to add search into their applications. With Azure Search, we have now simple search service that we can use for custom data. Azure Search makes it easy to add powerful and sophisticated search capabilities to your website or application. So with that, if you have any questions, you can type into your window, and Noor can help us with these reading those questions. So Noor, over to you for any questions.
Thanks, Abhishek. Thanks for the quick demo and the quick session on Azure Search. It's pretty simple to see how cloud search is useful for web as well as mobile app development. Yes, I do have a few questions coming from the audience. Like, we have a couple of more minutes. The first question is is Azure Search going to be on-prem or it will be always on cloud?
Azure Search will be on cloud only. So you can. It will not be on-prem. It will be on cloud, and from your application, which whether you are running it locally or your application is running on cloud, from your application you can call the Azure Search service to get the desired results.
Thanks, Abhishek. So here is another scenario. For example, is it possible to upload data in a phased manner? That is, say if first I upload data of a person and later I want to upload the address and other details of the person. So is it possible with Azure Search?
Yes, you can do that. You have to update your document using the merge action. So with the merge action, you can do that. Whatever the details earlier, you can merge the additional details on top of that.
Cool. So the other question is how to use multiple tables from database while creating an index in Azure Search.
Okay. So if I understand your questions, you wanted to use multiple tables from database while
database.
Okay.
That's right. Yeah.
So let's say you have two tables, say for example, table 1 and table 2. So in that case, you create a data source 1 that points to table 1 and indexer 1 that points to data source 1. After that, then create another data source, say data source 2 that points to table 2 and indexer 2 that points to data source 2. With this approach, I think you should be good.
Sure. Thanks. Thanks, Abhishek. So the last question is like, what does the EDM stand for? Like you did mention about the EDM in the middle, but can you elaborate and how is that useful?
Yeah, EDM stands for basically entity data model.
Okay, cool. That's good. So we have a couple of more questions coming in, but in the interest of time, we would like to take those questions offline. Again, thanks everyone for taking time to join this webinar, and I hope you found it informative. As you can see on the screen, our next webinar is on Azure Service Fabric, okay, which is on June 15th at 9 a.m. Pacific time. And we look forward to you joining to this next webinar. Thanks and have a good day. Thanks, Abhishek, for the wonderful session.
Thanks everyone for joining. Yeah, thanks a lot.